So yes, so third unit is completely dealing with analog as well as digital, we can say. Here in the first part we have JFET and MOSFET. So in the second unit actually we have started discussing about the transistor. So transistor is of two types we have seen. So first type is BJT, bipolar junction transistor, and second type is the field effect transistor. So complete discussion of BJT is done in second unit. Now in this third unit, we are going to discuss about this FET, field effect transistor. So field effect transistor is again of two types, junction field effect transistor and metal oxide semiconductor field effect transistor. So in the syllabus, we have both these types, JFET construction and its in VI characteristics. Similarly, MOSFET and its construction, VI characteristics. After discussing this construction and characteristics for both these types, JFET and MOSFET, next discussion is on the types of amplifiers by using this JFET, that is two types similar to BJT. We have common source, common drain, and common gate amplifiers. In syllabus, we have these two, common source and common drain amplifiers, along with their low frequency analysis. And so let us get back into this FET. Okay, so let us quickly once revise what we discussed related to this BJT. So BJT means bipolar junction transistor, which has the two PN junctions, and it can be operated in three modes of operation: active mode, cutoff mode, and saturation mode. So active mode means depending on the biasing, when emitter base junction is forward biased and collector base junction is reverse biased, then we say that BJT is operated in active region. Similarly, when both the junctions are reverse biased, then BJT is operated on the cutoff region. When both are forward biased, then we say that BJT is operating in the saturation region. So these are the three modes of operation. And in BJT, the current conduction is due to both the types of charge carriers, majority as well as the minority charge carriers. So that is why we call it as bipolar junction transistor. So whereas FET, the current conduction is due to only one type of charge carriers, that is due to majority charge carriers. So that is why we call it as unipolar junction transistor, FET or unipolar junction transistor. Now let us see this differences between BJT and FET. So because this is very important question. So previously also it was asked the differences between BJT and FET, or else advantages of FET over BJT. So these also may be asked in the examination. Okay. Now let us quickly see this. So BJT. So BJT is called as current controlled device. So because the output current, that is collector current, depends on the input current, that is IC is equal to beta times of IB. So this relation we have seen already in the second unit. So where IC is the output current, IB is the input current. Output current depends on the input current. So that is why output current is controlled by the input current. We call the BJT as current controlled device. So BJT is current controlled device. So whereas in case of FET, the output current, that is ID, output current ID is controlled by the input voltage, that is VGS. So as VGS is controlling output current, then we call this as voltage controlled device. Input voltage is controlling output current. So this is output and this is input voltage is controlling the output current. So we call it as voltage controlled device. So this is the difference, one big difference between the BJT and FET. Now let us see the differences here. So first thing, full form, and second thing is current conduction is due to both types of charge carriers in BJT, and here the current conduction is mainly due to the both types here, and whereas here the current conduction is due to only one type of charge carriers, that is majority charge carriers. And here operation depends on both majority and minority, here only on majority charge carriers. Current controlled device, FET is voltage controlled device. And here these are very simple things, and apart from this, what you need to remember is input impedance. This is very, very important. Input impedance is very less here in case of BJT, because in BJT emitter base junction is forward bias. Forward bias resistance is very small compared to the reverse bias resistance. Whereas in case of FET, the junction between gate and source is reverse bias. Gate source junction is the reverse bias. Therefore, here the resistance is very high. Here the resistance is, because it is forward bias, resistance is very less. Here the resistance is very high. This is very big difference. BJT is having less input impedance and FET is having high input impedance. Next, output impedance. So this one you can see output impedance is high and here it is low for FET. So this one also you can remember. So both are opposite. Input resistance is less and output is high for BJT. Whereas for FET, input resistance is high and output resistance is low. And the terminals of BJT, we all know, base, emitter and collector. Coming to the FET, the terminals are called as gate, source and drain. And the biasing of BJT is very easy. We have seen voltage divider bias and fixed bias. So similar biasing techniques will be there in FET. So these are somewhat complex compared to this BJT. Next, power consumption is high in case of BJT, whereas it is less in case of FET. So because here we may have higher currents in BJT. So that problem may not arise in FET. So here the power consumption is less compared to BJT. So that is why coming to the applications, generally the applications of BJT are, they are used as amplifiers, oscillators and switches. So the same applications are there for FET also. FET is also a transistor. So it can also be used as amplifier. It can also be used as oscillator. It can also be used as switches. Okay, now whenever you come to amplifier case, so because amplifier needs more gain bandwidth product, so we generally go with the BJT because FET is having less gain bandwidth product. FET is gain bandwidth product is less in case of FET. So that is why BJTs are preferred for amplifiers. And coming to switches, so these switches are, for switches, FETs are generally preferred. Okay, because they provide higher switching speeds. Okay, so these are the main differences. Now, next thing, noise is more because we have two types of charge carriers. Noise is more in BJT. We have only one type of charge carriers majority. So noise is less here in FET. Next, frequency variations. So frequency variations definitely affect the BJT. So frequency depends on capacitors, internal capacitors, network capacitors. All these things we have seen for BJT. And coming to FET, so it is having good frequency response compared to the BJT. Next, coming to thermal stability. So this is very, very temperature dependent device. Okay, that is unstable because as temperature increases, we have seen IC is equal to beta times of IB plus 1 plus beta into ICO or ICBO. So this equation clearly tells us output current mainly depends on these factors, beta, IB and also ICO, reverse saturation current. As temperature increases, these three factors changes which definitely affect the output current of BJT. So this is very temperature dependent device. Coming to the FETs, they have somewhat better capability compared to BJT. And because this is generally because for BJT, as the temperature increases, resistance decreases. As resistance decreases, current increases. As current increases, what happens? As current increases, power dissipation increases, which may damage the transistor. So that is what the thermal runaway we discussed for BJT. Now coming to FET, as temperature increases, the resistance increases, so which decreases the current. So there is no problem of thermal runaway in case of FET. For BJT, as temperature increases, Resistance decreases, so current increases. As current increases, power dissipation increases, which may damage the transistor. But in case of FET, as temperature increases, resistance also increases, which decreases the current, so which decreases the power dissipation. As power dissipation decreases, no problem. It can afford more heat. So that is why FETs are better stable compared to BJTs. Next, coming to the cost wise, so BJTs are cheaper and FETs are costlier. So BJT it may available for 10 rupees. Coming to FET, the cost of FET may range from 50 to 100 rupees. Okay, next coming to the size of BJTs is large compared to FET, whereas these FETs are smaller compared to the BJTs. So that is why in most of the digital circuits, we will use FETs compared to BJTs. So BJTs are used for analog circuits where we require amplification process or amplification application. Coming to FETs, FETs are having smaller size and therefore they can be used conveniently in the larger number in digital systems. So that is why they are preferred in digital circuits. BJTs are preferred in analog circuits. Now, few more differences we can see. The offset voltage, which is present in case of BJT. So offset voltage means whenever the applied input voltage is 0, even though when the input voltage is 0, there exists small output voltage due to noise voltages. Okay, due to noise voltages. So there exists some offset voltage in BJT. So the problem is not there in case of FET. So this offset voltage will not be there. Next, coming to the gain. So gain is more in case of BJT and it is less in FET. So this one we have also seen in the lab. So around 40 dB we got for common emitter amplifier. So this is around 20 dB for FET, a common source amplifier we have seen. So gain is less in case of FET and it is more in case of BJT. So this is the only one disadvantage. So gain and bandwidth. Gain bandwidth product. So here gain is more. So gain bandwidth product is also more. So this is more. Whereas this is less. So this is the only disadvantage of FET compared to BJT. Next thing. So this is also becomes very important one. Gain and also frequency response. Next, voltage gain is high, current gain is low. Whereas here, voltage gain is low and current gain is high in case of FET. So because for FET, the input junction is reverse bias, current is almost 0, but will get higher current. So it is current gain is high in case of FET. Next, potentials, these things, these are very simple. You can go through them. Switching time is faster in FET, so that is why they are preferred in digital circuits. And a small current is required to keep this BJT device on. And here we require small voltage because here output current depends on input, whereas here output current depends on input voltage. Next, temperature quotient is negative here, means current as temperature increases, resistance decreases. So negative temperature quotient. Here we have positive temperature quotient. As temperature increases, resistance also increases. This is the positive temperature quotient is there for FET. Next, sensitivity is more for changes here, less for changes in the input voltage. Next, applications. So lots of applications are there. Main applications, amplifiers, oscillators, multivibrator,